Have you ever watched a video of a massive iceberg breaking off a glacier? It's an incredible, powerful sight, but what you see on the surface is only half the story. A groundbreaking new study has revealed what's happening deep beneath the waves. And the findings are a game changer for understanding climate change. For the first time, an international team of scientists has used fiber-optic technology to listen to the underwater chaos that follows a calving event. When a huge chunk of ice crashes into the ocean, it doesn't just create a splash. It triggers a chain reaction that dramatically accelerates the melting of glaciers. This isn't just about icebergs floating away. It's about a hidden feedback loop that's eating away at the world's ice sheets from below. So, what exactly did they find? The team, led by researchers from the University of Zurich and the University of Washington, went to southern Greenland. They studied a fast-moving glacier called Iceberg Kangalite Sermiat. To give you some perspective, this single glacier releases about 3.6 cubic kilometers of ice into the ocean every year. That's nearly 3 times the entire volume of the Rhine Glacier in Switzerland. To peek into this dangerous and dynamic environment, the scientists laid a 10-kilometer-long fiber-optic cable on the sea floor right in front of the glacier. This wasn't just any cable. It acted like a super-sensitive microphone, stretching for miles. Using a technique called distributed acoustic sensing, or DAS, they could detect even the tiniest vibrations in the water. Every crack in the ice, every splash from a falling block, and every wave that rippled through the fjord was recorded. Think of it like this. The cable acted as an array of thousands of hydrophones, listening to the secrets of the deep. Lead author Guminic Gerf explained that this technology allowed them to measure all the different types of waves generated when an iceberg breaks off. And this is where it gets really interesting. When a colossal piece of ice falls, it creates a massive surface wave-calving-induced tsunami. We've all seen videos of these waves. They're powerful, and they mix the top layers of the water. But the science team discovered something else, something invisible from the surface. You see, Greenland's fjords have a unique structure. The fresh, cold meltwater from the glacier is less dense, so it sits on top. Below it is warmer, saltier, and denser ocean water. When the surface tsunami mixes these layers, it's just the beginning. Long after the surface of the fjord becomes calm again, giant waves continue to move underwater. These are called internal waves, and they travel along the boundary between the cold, fresh water and the warmer, salty water. These are not small ripples. The researchers found that these internal waves can reach heights comparable to skyscrapers. Imagine an unseen underwater wave as tall as a 50-story building rolling through the fjord. These powerful internal waves act like giant stirrers. They continuously churn the water column for long periods, bringing that warmer, saltier ocean water up from the depths and pushing it directly against the glacier's face. Professor Andreas Vili, a co-author of the study, explains that this warmer water eats away at the base of the glacier's ice wall. This process, called melt erosion, destabilizes the front of the glacier, making it even more likely that another large piece will break off. It's a vicious cycle. Calving creates internal waves. The waves bring up warm water. The warm water melts the base of the glacier, and the melting leads to more calving. Dominic Goerf calls this an incredible calving multiplier effect that they were able to measure for the very first time, thanks to the fiber-optic cable. Before this study, scientists knew that the ocean was melting glaciers, but getting detailed measurements was incredibly difficult. Fjords full of icebergs are hazardous places. Sending in ships or underwater drones is risky, and satellites can't see what's happening beneath the ocean's surface. As Professor Veli put it, previous measurements had often merely scratched the surface, so a new approach was desperately needed. This new data is crucial because the Greenland ice sheet is massive, about 40 times the size of Switzerland. If it were to melt completely, global sea levels would rise by about 7 meters, or 23 feet. That would inundate coastal cities around the world. But the impacts don't stop at sea level rise. The massive influx of fresh, cold meltwater into the North Atlantic can also affect major ocean currents, like the Gulf Stream. This current is like a giant conveyor belt of heat that helps regulate Europe's climate. Disrupting it could have far-reaching and unpredictable consequences for weather patterns across the continent and beyond. The delicate ecosystems within the fjords themselves are also threatened by these rapid changes. The research highlights just how interconnected our planet's systems are. As Dominic Goerf warns, our entire Earth system depends, at least in part, on these ice sheets. It's a fragile system that could collapse if temperatures rise too high. What this study really shows us is that the processes driving climate change are more complex and interconnected than we previously realized. The dramatic, visible spectacle of an iceberg calving is just the trigger for a hidden, powerful mechanism that accelerates the very problem. By understanding these multiplier effects, scientists can create more accurate models to predict the future of our ice sheets and the rate of sea level rise. This pioneering use of fiber-optic technology has opened a new window into one of the most important and inaccessible environments on Earth. The data gathered will be vital for future efforts to document calving events and understand the rapid decline of ice sheets in Greenland, Antarctica, and elsewhere. It's a stark reminder that the consequences of a warming planet are playing out not just in the air we breathe, but in the hidden depths of our oceans. Thanks for watching. If you found this look into the hidden world of glaciers fascinating, please give this video a like and subscribe for more deep dives into the science of our changing world. Let me know in the comments what you think about this new discovery. See you next time.